found ways to calculate that. Now let's look at that data again, except this time, instead of going through this entire calculation, we'll just use the built-in values that Excel is going to provide us with. So I'm going to open up another file here. Or actually, I think it's the same numbers. You can use that same file if you want to. Okay, I think this is the same file. I'm not positive. Okay, so I'm going to use these. I'm going to use these values, and I'm just going to go ahead and calculate. For instance, the mean. It's built-in value. There's a built-in function called average. Parentheses. Now, when I type a function into Excel, if I'm aware of what the function is, or I think I can guess at it, I can type in an equal sign, indicate to Excel that in that cell is going to be a function. Then I can type in that function. When I get to the end, it'll actually, if you're typing in a function that exists, it'll actually prompt you for varieties of that function or spelling of that function. And when you get to the end, if you put in open parentheses, it'll prompt you for the parameters, the information that needs to go into those parentheses in order for you to complete the function. In this case, it's the list of numbers. Okay, so I can, of course, for those of you that don't use Excel too much, I can actually indicate this list of numbers by typing an A2 colon A19, or a better shortcut is just simply, while I have that open parentheses there, just click into the first cell without lifting and drag down, and it'll fill in the range of values, the cell range for me. Close the parentheses and hit enter. And I got my average, right? Pretty straightforward. Okay, so now let's do the same thing for median. Okay, and in fact, as I'm typing, I can see that there is a function that exists that's in here that'll calculate the median for me. Again, I hit parentheses, and I'm ready to input the range of values. Okay, and there's my median. Okay, I'm gonna do the range. Now, unfortunately, I'm pretty sure there is no value there for range. Okay, so the range is just the maximum minus the minimum, right? So in fact, there is a function for maximum, and there is a function for minimum. I can calculate equals minimum, min, min, parentheses, and max equals max, parentheses, and then subtract one for the max from the minimum. But I'm gonna shortcut this a bit. I'm gonna say equals max, parentheses, and give it the range of numbers for the maximum. It's going to pick out the largest number there, minus min, parentheses. So I'm going to combine them into a single function. This one's pretty simple, and a lot of times when you have to do that, when you're doing this, you have to be a little careful with the parentheses, but in this case, it's pretty simple. And the range is 26. Okay, there's our range, there's our median, and there's our mean. Okay, how would I indicate the mean? Is that going to be mu or x bar? Yeah, x bar, right? Anytime we're talking about a population mean or population parameter, we're going to use a Greek letter, and when we're talking about a sample, we're going to use regular English notation. So median, we have the range. Okay, so now what are we missing now? We have two measures of where the center of this sample is, right? Hopefully it also kind of represents what the population is also. Another kind of measure of where the data is predominantly, which is a little bit you're just talking about, it's more appropriate to use it for nominal data than for numerical data. We can actually calculate a mode. Okay, the way Excel is going to handle this is it's just going to throw me back the most frequent value in here. Okay, now if these are decimal values, it's entirely possible none of them are the same, right? So it really doesn't make much sense to describe a mode. In this case, they're all integers, so we're likely to get some number that's going to be a mode. In this case, 104. Okay, so what does that tell us? That tells us the most frequent value is 104, and the difference between the minimum and the maximum is the range. So now what I'm going to do is I'm going to confirm that now. I'm going to take these values, and I'm going to highlight them, and I'm going to go on my Mac, it's Command C. If you got a PC, it's Control C. I'm going to go over here somewhere where there's not a lot of stuff, I'm just going to paste them in here. So I have a list of numbers now. It's still highlighted now that I pasted it in. I'm going to go up here to Tools. It's going to look a little bit different on your PCs. They use a ribbon. Yes. What's that? Yeah, there it is right there. Okay, go to me, go to meet.me/CUNY Health Sciences. Okay, I'm doing this because while I do this, I can broadcast it, I can record it at the same time. That's why I'm doing it. The only reason I put that up there is because you guys in the back might find this hard to see. So you can actually see my screen, my window, with the windows here right up front, and it'll open in a window. So if you want, you can move that out of the way temporarily, work with Excel, and then open that window back up. Pull that window back up if you want. So I don't know, is it working okay? Is that working all right for you? I know in the other classes they kind of like that because in those labs they were most of them are lined up vertically like this. So in order to see the front, they will have to crane their necks around. Exactly. Yeah, got a little tiring after a while. Okay, so now I have the statistics here. The data that I wanted to work with. Now I'm going to sort it. Okay, I want to see it in a sorted order from lowest to highest number. I'm going to go up here to data on the Mac. Again, it's going to be a little bit different on the PC. Say sort, and a little window pops up, and the window's popping up to warn me that if I have several columns of data here, for instance, if the first column is a subject number, second column is their weight, their blood, the third column is their blood pressure, and so on and so forth. If I sort one column without sorting all the others, I'm going to disconnect that data. It's all going to be mixed up. It won't be related anymore. It's asking me if I want to spread this up, spread the selection all the way over to the left. So I'm sorting all of the columns together. Well, in this case, I just want to sort this one column. So I'm going to say just continue with the current selection, just this row of numbers. I'm going to click sort, and there it is. Okay, so the lowest number is 88. Highest number is 114. 114 minus 88 is 14, and 12 is 26, and in fact our range is 26. Okay, how about our mode, most frequent value? Well, there it is, right? There's 304s. There's no other 104s. Okay, how about our median? Now Excel gets a little funky, does weird stuff when it calculates medians and percentiles. Okay, so you have to be a little bit careful. You may not get the same answers in Excel that you get in other software packages that are dedicated statistical packages. The best recommendations I've heard on this is that if you're doing percentiles and you're doing statistics that are likely to be different in Excel than they are in SPSS, is don't do it in Excel. Do it in a real statistical package. But in this case, most likely what's going to come up here is it's going to average the two middle values, right? We have 18, so there's no middle value. So it's going to average the 9th and 10th value. And in fact, that's what it does. Average of 99 and 101. So we see that this actually is working. Okay, so now let's calculate the variance, right? Before we actually went through that painstaking process of calculating the whole thing, now we're going to calculate the variance using a command in Excel, VAR, right? Parentheses. Again, and there's several different methods that it has for calculating variance. For our purposes, I'm just going to use VAR. Okay. And I'm going to highlight those numbers. Actually, I could use either list. And I'm going to hit enter. Okay, so now that's my variance. Okay, and if you don't know if a statistical function exists, you might want to click in, see a little f of x, function of x button. If you have your screen, if you're using your screen, you can actually see it most likely. It's really tiny. It's up in here. If you click on that, that will give you a list of all the statistical functions that are buried in Excel. In fact, all of the functions. And you can scroll down to it. You can search for functions. If I get into the right spot here, you'll see a whole list of the various statistical functions that are here. There are add-on packages for Excel that will add in additional functions that are not here to start off with. Okay, and these functions that are on the Mac are not as robust as the functions that are on the PC version. So, for instance, dirty little secret, I think there is a function for range in the PC version, equals range or something like that. But there isn't one in the Mac. Okay, so variance, we calculated the variance equals VAR, parentheses, A2 colon A19. Now, I'm going to check that. Okay, well, actually, I'm going to calculate the standard deviation now. Now, standard deviation, am I calculating S or sigma here? Is that S or sigma? Well, if it were sigma, what would I be implying that is? Greek letter, I'm implying it's a parameter. It's the population standard deviation. It's not, right? It's just a sample standard deviation. Well, there's a couple of ways I could do this. One way is I could actually just calculate the square root of the variance. And there is a function in Excel for square root, SQRT, parentheses. I'm going to click in that box so I don't have to copy that address. And I'm going to enter. And it comes out to be 7.25. I'm going to now test the standard deviation function in Excel as well, STDEV as it happens, parentheses. And I'm going to find the standard deviation of this list of numbers. Okay, and there it is. Okay, any questions on that? Pretty straightforward, right? Right, pretty easy. I see a couple of puzzled looks there. Right, is there a question on that? Okay, there's a homework. You know, one of the things on homework assignment is to do many of these calculations and then to save the Excel file and then upload it to Blackboard. How many of you guys have first semester here? Yeah. Okay, you guys comfortable with Blackboard uploading files? Have you been to the assignment and stuff like that? Not yet. Okay. When you get a chance to do it, when you get a chance to do it, let me know if you have any issues with it and stuff. Okay. Now the assignment is due September 18th. Now secretly, don't tell Levi this. Okay. The syllabus has a very rigorous treatment for late homework assignments, right? You probably read it. If you're late a half hour, you get a point off. If you're late 7 hours, you get 2 points off. If you go back in time and resubmit it, you do that. I have a special policy. I think it's important that you keep up with this work and you try to homework. It's very simple. This stuff so far pretty simple. As it gets a little bit more rigorous, a little bit more difficult, it's tempting to kind of let it drop a week or two or something like that. It's really important, since we're building on all the stuff that we're doing, that you don't fall out, you don't drop out on us, okay? So I secretly have a policy that if you at least make an earnest effort at the homework before it's due, anytime after that you can go back and redo it. In fact, right now it's set up so you have an unlimited number of tries on the homework. So I know there's a few things in there that could be a little confusing, but even in this, it's simple, this earlier homework, okay? And the way that's going to work is like right now, if you were to go on it and you got a 70% or 80% on homework, you could immediately go back and just do it again. The only disadvantage with this homework is that this one, I'm asking you to upload an Excel file and also to use SPSS to create some charts and tables, copy them into a Word document, and then upload that Word document. Okay, there's a few reasons for that. One is that in the future, in real life, you're not just going to send people outputs from SPSS. You're going to have to copy and paste and use and select and design those tables and charts so they make sense to people. So I'm going to ask you to do that with Word. So that does two things for us. One, it gives you practice on doing it and using SPSS in the real world, even in fact in other classes if you have them now. But it also means that I know that you've been forced to find some way of working with it, getting access to SPSS, whether it's your personal copy, a copy of work, virtual desktop, or something like that. I know you've gotten to the point where by the third week that you really have access to it. So the only downside is that when you submit something online, I have to open the file, read it, and grade it. So you won't get immediate feedback. I try every couple of days to go on there, and I won't go on like every 2 hours. kind of compulsively to check to see if anybody else has submitted the homework. But you'll see that every day or two now, from now on until it's due, I'll be going on to grade whatever groups of homework have been added. A lot of people, I'll see them, they'll do the homework once, they'll do it again and again and again. They may do it 5 times until they get 100 on it, right? 2 good things about that. One, it forces you to keep up. If you really, if you take advantage of this, it forces you to keep up. Number 2, if you're determined and you get the homework done, there's no reason why you shouldn't get 100% on the homework. That's 30% of your grade. And that can go a long way to moderating like a little problem, a little hiccup you get on one of the exams. Okay, because we only have 2 exams. So it's easy to kind of like get surprised by a problem or something like that. So it really makes sense to grab that, that grade on the homework to make sure that you don't get sabotaged if you make a little mistake on an exam or something like that. Okay, so at any rate, so I really encourage you to keep up with that. I apologize, but you have to wait for me to grade this particular one. Most of the other homeworks are going to be set up so that they will auto grade and you'll get feedback right away. Okay? Okay, no, good. So this is where we are with Excel. Now, let's do this again with SPSS. Okay, what I'm going to do is, I'm going to do 2 things. One thing is I have another version of this file, which is called Descriptive Statistics Excel to SPSS. It's also an Excel file, but I set it up a little bit differently. First of all, let me blow it up so you can actually see it. Okay, so here, same numbers that we were talking about before, same data, same 18 subjects. I'm going to make believe, I don't know what this is, I made these numbers up. I'm going to make, there's actually, believe it or not, a function in Excel where you can create a series of numbers that are normally distributed by giving it the mean you want and the standard deviation you want. So this was created that way. It's 18 numbers, probably fairly normally distributed, but in the previous version, we had them on a spreadsheet that had a lot of detritus on it, a lot of other stuff, a lot of other text and labels and so on and so forth. In this case, I've organized the data so it's a single line, it's straight up and down. Okay, I'm going to go a little further here. I'm going to say to myself that I'm going to add in a row in here. Whoops, insert row, okay, right at the top. And I'm going to put on the top of this column BP to indicate that those are blood pressures for each subject. And then right next to that column, I'm going to go into B1 and I'm going to type in gender. Right? And I'm going to add in some additional data. I'm going to identify each one of these people in this study as either being male or female. Now, I'm not going to type in male and female because that can be a little bit tedious, number 1. Number 2, if I capitalize female and then I also use a version of it that's not capitalized, the computer, SPSS, Excel won't see that as the same thing. So it's a little bit more efficient to identify gender by substituting a number for it. Okay, so I'm going to call males 1 and females 2. So I'm going to say the first 10 people in here are all males. Okay, and the next 8 are all females, 2. Okay, so if I had a little notepad over here, I would go on the side and I'd say gender, 1 equals male, 2 equals female. I'd create a code book, a book which indicates what this data stands for. Oh, BP is a numerical variable. It can have 3 digits, so many decimal places. Gender is a nominal variable or categorical nominal variable. It can have 2 values, one for male and female, 1 equals male, 1 equals female. So I could create a little history, a little code book that tells me what this data represents. Okay, so I have this data now. I'm going to save this file. Okay, and I'm not going to save it under the same thing. I'm going to save it on my desktop. I'll give it a new name. You can give it any name you want. I'm going to call it class exercise. You can call it anything you guys want. I just want to be able to find it again when I'm done. Okay, now SPSS, I haven't tried it with the current version 25. but earlier versions, I know 23 and lower, will not tolerate importing a file from Excel if the file is still open in Excel. So I'm going to close Excel. I'm going to quit Excel. I'm not going to be using it, I don't think, again today. So I'm just going to, rather than just close the document, I'm just going to quit the program. Okay, so now we have a document which represents the data that we were just working with, but it's an Excel file. But it's organized so that each column represents a different variable. The first column represents a numerical variable called BP. Second column represents a categorical variable called gender. Okay, and that's exactly the way that SPSS organizes data, in vertical columns for the variables, in rows for the individual subjects, cases or subjects. Okay, so that means it's going to be easy for me to import this. So I'm going to open SPSS. It'll bounce up and down for a while. Okay, I'm going to get rid of this opening window. And here's my sheet, my data file for SPSS. It's empty currently because that's just a new data file. And it's got two sides, a data file and a variable file, right? Front and back. Okay, so this is a single window with two views. Okay, so now I'm going to import the data that I had in Excel. So I'm going to go up to File, Open, Data. I'm going to navigate to the desktop. This could be one of the places that's a little bit tricky when you use the virtual version, because you got to navigate you got to navigate off the server to your desktop to get the data that might be there. Okay, so now I'm on my desktop. I don't see this file that I just created, right? Anybody know why I didn't see the file? Right, it's looking for SAV files. See down there it says .sav files. It's only looking for files of its own type, its own data files, right? So I have a lot of options if I click on that. I could look for SAS files. I could look for CSV files. CSV are comma delimited files, right? And if you're using R, most of the time you'll see me offer you data in three forms. It's an Excel file, as a SAV file, and as a comma delimited file for those of you that are using R. Okay, so if I scroll down here, I can see one of the choices here is Excel, right? Various versions of Excel file, .xls, .xlsx, and so on and so forth. Another option here is all files. If I click on that, I'll see all the files. That can get pretty confusing if you have a lot of junk on your desktop, like I always do. So I'm just going to tell it to show me the file that I know I'm looking for, which is Excel files. And if I look over here, sure enough, there's class exercise.xls. And I'm going to say double click or say open, and it will import that file. But before it imports that file, it's going to inspect it for you, right? And what does it do when it inspects it? Well, first thing it says that file has data in the range of A1 through B19, which sounds right? That confirms what we expect to see in terms of the data that's present there. Okay, two rows, A1 through A19, and it says, well, okay, let's see. It says read variable names from the first row of data. Remember, we added that row and we had BP and so on and so forth. We want that checked. If you look at that gives you a little, this is new in the last few versions. If you look at the summary of what that's going to look like, you can see that it understands that those are the variable names, not data. If I had not added those names, right, I would want to make sure that that's unchecked, because otherwise what it would have done is it would have thought that first number on that column was the variable name, use it as a variable name, and then you would have lost one of the subjects in your trial. Okay, so I'm going to leave that checked for our purposes, and I'm going to say OK, and it's going to import that data. And again, first thing we're going to see is on the, it really frustrates me, but IBM really hasn't done a lot of work in terms of like working with the user interface on the Mac on this, or the PC for that matter, right? Because on most applications, I can blow this up. I can like kind of squeeze out my trackpad here and make it a little bit more visible to you, or increase the size of this. I can, the only way I can do it here is to change the resolution of my screen. I don't want to do that because it'll screw a lot of stuff up that we're doing now, including possibly the recording. So, but hopefully if you can see this, or at least you know what I've done so far in Excel, it'll make some sense to you. Okay, so in the first column is BP, the second column is the variable gender. So if I want to examine those variables more closely, I can go to variable view. Okay, and this basically is a form of a code book on the other side, a description of each variable. So each row now represents a column on the other side of this page. So BP is the variable name. That's what's at the top of that column. SPSS only accepts letters and numbers for variable names. They can't have special characters and they can't have spaces in them, which is inconvenient because sometimes you wind up with things that are pretty cryptic for variable names. Well, there's a way around that. And the way around that is there's another column here called label. And you can type in anything you want there. For instance, I'm going to type in blood pressure of students. Okay. Okay, so from now on, whenever SPSS creates a chart or a table, instead of using BP to label that chart or the table, it's now going to label it with that more descriptive label that I've created there. For gender, I'm going to put sex of subject. I could even put special characters in there if I wanted to. Okay, now before that, you'll notice that it defined both of these as numeric. They are numeric, right? Even though it's a nominal variable gender, it's a number that it's being indicated by. No problem with that. It automatically judged what the maximum width would be to give it a little bit space, so that the blood pressure was up to 3 characters wide. If I go over a little bit further, it has a column where I can define what I want to do with missing variables. If you don't do anything, it'll ignore missing variables, which is okay for us for right now. Just simple housekeeping like alignment. And then the next important column is measure. And in that measure, it's guessing at what kind of variable it is, right? So inspected the data, and it says, boy, that first variable, BP, looks like a scalar variable. SPSS uses the term scalar for a numerical variable. Okay, so it guessed right. That's what it is. Now for gender, it saw it was only 1s and 2s. It took the guess nominal variable. It won't always get this right. It's important that you check when you import new data. You check to make sure that it's properly identifying the variable type. Now, the only problem I have now is that I've told SPSS that the gender for all these people is 1 or 2. I haven't told it what 1 or 2 represents. So if you look at nominal variable, the nominal variable, your gender, there is a box over here called values. If I click into that box, a little drop box next to it appears, and I can click into that, and it will allow me to indicate to SPSS what those numbers, those codes mean. So one was male, right? 1 was male. I click add, and 2 was female. Now, don't click OK, because it won't take it. You got to click add, get that into that output box, and then click OK. Okay. So now, if I go back to my data view, here's my data view. My data view now shows, instead of 1s and 2s, it shows the actual values for males or females. If I don't want to see that, I actually want to see the raw data, you can go into view and you can toggle that value label, that translation off and on. See, there it is as numbers. There it is as the actual value that it represents. Okay, so, we're in pretty good shape so far, right? So in many data files, including one that you have tonight that's on Blackboard, has many variables and has many subjects, right? Not just this abbreviated set. We're just working with this one because we know what our answers should be when we start doing some of these calculations. So I'm going to go in here, and now I want to actually do some analysis of this data. I want to create some descriptive statistics. Okay, so I'm going to, first, I think I'm concerned about, well, what's the distribution of males and females in this sample? Are there more males than females? If there are, how many? So I'm going to go up here to Analyze, Descriptive Statistics. Well, first of all, I'm not interested for a nominal variable in the statistics that we would associate with numerical variables. Mean for males and females, meaningless. Standard deviation is pretty much meaningless, right? I want to do counts. I want to count how many males and females there are. I want to produce charts that show me comparatively how many there are, what percentage are males and females. So I'm not looking at histograms here. I'm looking at bar charts. I'm looking at column charts, bar charts. I'm looking at maybe pie chart. Okay, and even. Okay, so I'm going to go in here, instead of going to descriptives, I'm going to go into frequencies, because that's what we're interested in when we deal with nominal variables. It's really frequencies. Okay, so frequencies is just another way of saying counts. Okay, so I'm not interested in, now I have to, there's two variables. SPSS needs to know what variables we actually want to work with right now. So I'm going to click on sex of the subject, which was gender. If I hover over this, it'll come up and show me gender also. Okay, I'm going to move that into the into an area where it lets me work with what I need. Now, it gives you a button called statistics. I don't know why that's there, but it's there anyway. We're not going to use it, obviously. Okay, but I can go into charts, and it gives me the opportunity to create a bar chart. Well, histogram's not really applicable here, right? So bar charts, so you have to lose a little bit of judgment. SPSS is not always going to make the right decision for you absolutely foolproof. Okay, and again, they could have, but they didn't. Okay, so I'm going to make a pie chart just because I know Levi doesn't like pie charts. Okay, statisticians typically don't like pie charts, so we'll make one. Okay, so now you have a choice. That pie chart can represent the labeling or represent frequency, number of males, number of females, or it can represent the percentage of males and females. I'm going to leave it frequencies. I'm going to click OK. And now what happens now is an output window opens up. And this is a completely separate window. It is not stored when you quit SPSS and you save your data file. It does not save the output file. Completely separate from your data file. There's other windows in here as well, syntax windows and so on and so forth, where you can work with to create programs or typed written instructions for SPSS to do various kinds of functions. And in fact, it's not just programming to get to automate them, but also some of that syntax also includes other extensions or choices for some of the functions that you have in SPSS, some of the statistical calculations you do in SPSS. So it's not just to the drop menus for us are going to be pretty much what we need. But as you get more advanced, there may be things in the syntax that are not easily available from the drop menus. Okay, so let's see what we got. Well, it looks like it's 50-50, right? 9 males and 9 females. I thought I did 10 and 10, but I guess I did 9 and 9. So it's 50%. There's a legend here: blue is male, green is female, so on and so forth. It gives me the frequencies. It gives me the percentages, 50% each, cumulative percentages, and so on. Now I can click on these boxes, open up a Word document, copy that, and paste it into the Word document. Now there's a few ways I can do this. Okay, and I'm really doing this right now, showing you this in a little bit more detail because I'm trying to avoid some of the pitfalls that you might run into. So, for instance, I know on some computers, for instance, I'm gonna copy that. I'm gonna say highlight it. It's highlighted. I'm gonna say copy. Of course, you can always use the shortcut. You can always use your keyboard shortcuts, and I'm gonna paste it into my Word file. Okay, when I paste it in, you'll see that it pastes it as a formatted text file, which means that you have the labeling. You can actually click in here and you can edit this table, right? It's literally just a text file with some extra formatting. Okay, so if you want to, you can change colors. You can it's a little tedious, but you can actually maybe spread it out, do some other stuff. That's a good thing, but it's also sometimes a bad thing, because if you have a really large table, wide table, you paste it in here, it extends out past margins, and then you have to resize everything. It can get very tedious. Okay, so on most computers, whoops, on most computers, you also have the option of saying paste special. And when a paste special window comes up, it gives you a number of different formats that you can paste this in. You, on 90% of you, are going to be able to paste it in as an image, right? One of the things that's going to be there is PNG file or a TIFF or something like that, and you can paste it in as an image. Good thing about that is it's a picture now. And a picture you can resize easily. Just grab the corner and resize it to whatever size you need. You can move it around the document easily, right? So downside is you can't edit the picture once it's in. Well, you can't edit the text in the picture once it's in your Word document. Okay, so it's a trade-off. You can, of course, edit the document or the table or whatever. And you notice I wasn't able to do that. Those of you that could see that little type, I wasn't able to do that. There's a bug in either my version of Word or in SPSS that doesn't transfer over the image file, the image information. Okay, so what you can do, you can actually double click on a chart or on a table, and it'll open it in a window where you have an editor. You can change colors, add titles, so on and so forth, highlighting and so on, change, edit, change numbers, which probably is not a good idea. Yes. Control C and Control V, right?
No, I mean, paste special.
Yeah, it should be there. It should be edit, under edit, paste. Oh, if you click down, you got to drop, like if you go over to the left-hand side where you have the little what is that, little clipboard? If you click on the little arrow next to the clipboard,
yeah.
Okay, then you should see paste special. Okay, so now this is not going to work in mine, unfortunately. You can edit it in, like I said, if you prefer to edit it, if you prefer to be able to move it around, handle a little bit more easily in Word, and you want to paste it in as an image, you can do that. And if it needs to be edited, you can do it in SPSS as well. That goes for the tables as well. Okay, so now my workaround for those of you that might come into contact with this problem, my workaround on the Mac is that there's a program called Grab. How many of you guys have Macs? Yeah, gluttons for punishment. There's a program called Grab. I don't know if you guys are familiar with it, but if you're on the desktop, you have your menu at the desktop is File, Edit, View, and Go. If you click on Go, it'll take you directly to the Applications folder or to the Utilities folder. I forget which one it's in. I think it's in the Utilities folder. You can go there. You'll find Grab in there. You can drag it down to your taskbar at the bottom so that it's handy there for you to use in the future. So if I want to copy this table as a picture and paste it into a Word document, I can go down here and I can click on Grab. And now Capture, I can go up to Capture at the new menu, and I can capture a selection, a window, a screen, even a timed screen. I can tell it, grab it in 10 seconds, so if I need to move something around. So I'm going to say selection. So I am going to just surround this box. It'll come up like that. Now I can either save this as under a variety of different formats, TIFF, PNG, JPEG, and so on and so forth. Give it a name and save it. In which case, I can always then copy it into anything, move that into anything I want. Or the other thing I can do is just simply, instead of trying to save it, just simply say copy. And then now that I've copied it, I should be able to paste it into a Word document. If I can find the Word document. There it is. See, now it's a Word document. And if it doesn't fit in my formatting, I can just resize it and move it around very easily. Can't change the numbers, can't format it anymore, but it's easy to move around and resize. Okay, so that's a little bit of a hint to maybe make things a little easier on you as you work with this stuff. Okay, so let's go back to what we examined that variable gender. Now let's go back and look at our numerical variable. little bit more interesting now because we have some other things that we can do with that. So I'm going to go here to analyze. I'm going to go to descriptive statistics. Except this time, instead of going to frequencies, if I go to frequencies, what's going to happen? I'm going to move this out, move in my numerical variable. If I go to frequencies and I find the frequencies, I'm going to make a pie chart. Okay, what's going to happen? It really doesn't make much sense, right? It's just listing all the values, especially if there's no duplicate value. I mean, you could have a data set where you're measuring like, blood lead levels, 5.3, 9.7, 1.0, but there's no duplicate values. All you get is a list of the numbers that you already started out with. So it really doesn't make sense to do frequencies or pie charts or bar charts with numerical data, most numerical data. Okay, so I'm going to go back again. And I'm going to say analyze. I'm going to go past frequencies, go down to descriptives. And that's going to give me my descriptive statistics for a numerical variable. It's really a pared down set of statistics. Again, I'm going to move it into my variables list. I'm going to go into options, and I can actually select what I want. Pretty limited group of options. Variance, range. I'm going to just about everything that might be useful to me. I'm going to click continue. And click OK. Yeah, my output window comes up. Look at my pie chart's pretty, right? Yeah. Okay, so at any rate, the table I just created is down at the bottom there. Here we go. There's 18 subjects, valid pieces of data. The range is 26, minimum 88, 114, maximum 99.94, standard deviation 7.247. Sound familiar? Same numbers we got in Excel. Only thing sometimes get a little bit funky is interquartile range and percentiles. Right? And that's because they may calculate them differently. So now, that's not very rewarding. I could use some more information. For instance, what happened to the variance? I know I can calculate the variance, but what happened to the variance? What happened to some other statistics I might be interested in? So I actually can examine this in a bit more depth by going to Analyze, Descriptive Statistics, going down below Descriptives to Explore, which is still Descriptive Statistics. Okay, and again, I'm going to move my numerical variable into my dependence list. Okay, and I'm going to click on Statistics. This time, it basically assumes you're going to want the full Monty. So it just says Descriptives, check. Right, so it's going to do basically everything that it's pretty much programmed to do. Something called, anybody here know what a confidence interval is? Okay, a couple of people have taken statistics before, right? Okay, those of you that don't know about it, don't worry about it. We're going to be beating that to death pretty soon. Okay, so I'm just going to kick off descriptive statistics. Typically, you'll see this come up at 95% a confidence interval by default. Don't worry about it for now. And I'm going to click OK. Notice it had no. Did you notice that there was a selection there for percentiles, or it'll calculate percentiles for you if you want them? I might as well leave that in there. Okay, I'm going to click OK, and again, now I get a more comprehensive set of statistics that describe the center of my sample, the variability, the range of variability of my sample, and so on and so forth. There's our mean. There's our median, variance, standard deviation, minimum, maximum, interquartile range, so on and so forth. Okay, some other stuff that we haven't worked with yet. Here's our percentiles here. You'll notice that maybe the interquartile range is not going to be exactly the same as it is. It's going to be close, not exactly the same as it is for SPSS, not for Excel. Okay, so now the other thing it gives you, I'm going to go back here for a second. Analyze, Descriptive Statistics, Explore. The other things it gives you is an opportunity to get some extra graphics, plots. If I click on plots, it says, hey, stem and leaf plot's going to be produced automatically. We'll talk about what that is. And histograms. Let's ask it to create a histogram for us. I'm going to click OK again. It's going to repeat the same thing we just did before. So what does it do? It does our table. It first gives you some feedback on the data, how many valid subjects you have. It gives you your descriptive statistics in detail, gives you your percentiles, and now we have our histogram, right? And it selected ranges that it thought was appropriate for us. We could go in there and select them. especially if you use the syntax. And you can actually click into this and you can change the ranges as well. So the next thing that it gave us is something called a stem and leaf plot. You guys remember? I think there was a slide tonight on during the lecture where you had a dot plot, showed each individual value as dots, piled up on like wherever whatever whole number was closest to it. That's kind of the same thing. So in other words, if the value was 88, right? You'd have 8, and then 88 would be represented by 88, and 89 would be represented by 89. So there's two numbers there, 88 and 89. So if the first digit is 9, well, there's a 93, and a 94. So 3. And then for 5 on, it's 96, 97, 99. So basically, you're getting a histogram kind of laid sideways. Here, can you see the shape of it there? It's just like your histogram, except it's laid sideways. Okay, and each one of these represents the last digit within that range of numbers, or what would have been the bin on a histogram. Okay, so it also creates a box plot for us, right? Here's our minimum value was 88, our maximum value was 114. There's our median. Median's not in the middle. What does that suggest to you? That the median is not in the middle of this range of numbers, in this interquartile range. What's that suggest? It's skewed, yeah. In other words, probably there's something at this end here that's pulling the average away from the median, right? Or up here, right? There's some numbers that go well beyond where we would expect them to be. So at any rate, so the histogram can give you a hint a lot about the shape of what the histogram might be like. Okay, so now the next thing I can do is, the next issue is, gee, maybe I'm not just interested in just knowing about descriptive statistics for this whole group as one group. Maybe I'm interested in doing a comparison here. Maybe I want to compare whether or not blood pressures in females in this population are different from blood pressures in males in this population. In order to do that, I have to segregate that data. I have to break up that data. In math, when you break stuff up, when you break up a number, you factor the number, right? Take a number like 30, you factor it into 6 times 5. SPSS takes advantage of that notation, that nomenclature. If I go down to descriptive statistics, go back to explore. Some of you might have noticed that when I went to explore, I moved in my numerical variable into my dependence list, that there's another box under here called the factor list. And what I'm going to do is I'm going to move in a nominal variable, a categorical or nominal variable into there, so that SPSS now understands that our objective here is to do descriptive statistics for blood pressure, but to factor them into 2 groups, males and females. Okay, so I'm going to click OK. And notice I didn't change. It remembers our settings until I quit SPSS. So I didn't have to go back and enter all that stuff again. So let's see what we wind up with. We end up with 9 males, 9 females. Here's our case processing summary. And then if I look in here, the mean blood pressure for males is 100 and 100. The mean blood pressure for females is 99, so there's a little bit of a difference. We have different variabilities, different standard deviations, and so on and so forth. It does percentiles for both groups. It actually creates histograms for both groups as well. Not much data here, so this doesn't make much sense, but it gives us these histograms. Okay, stem and leaf plots for both. But most interestingly, it creates a side-by-side box plot, right, for these groups. Okay, well, what does that allow us to do? That allows us to compare where the median is in both of these groups. Median for females is lower than the median for males. It allows us to compare the variability. The variability for females is much less than the variability for males. Remember, we just selected the first 9 numbers and the second 9 numbers for male and female, so this really doesn't make any sense in terms of real data, but we can apply this to more realistic data. Okay? And in fact, that's what you do in the homework, right? Okay, this is part of what you do. So in other words, One of the things we ask you for is a side-by-side box plot for some data. You copy and paste this into Excel. Let me see if it works for a picture. Copy. It's kind of variable too. Sometimes it works, sometimes it doesn't. Oh, you pasted it as a picture. So you knows it's a picture, but it just somehow or other it won't convert. You know, when won't automatically convert a chart into a picture the way it will on most machines, on mine. Okay, so okay, that's of some interest now. Let's apply this to some of the data that we're working with on the homework. So I'm going to open up a bigger file now. Open data. Okay, and I'm going to look for. Let's see. I'm trying to remember what file I have this in. I'm gonna have to go to my desktop to take a look. Oh. I don't remember the key sequence for that. Okay, test data, descriptive data. Nope, that's not it. Yeah. There it is. That's the file I want. Let me see if I can double click it here. Another bug. It doesn't recognize the SAV file. It's an SPSS file. Okay, open. Open. Okay, and I'm going to go to my desktop. And from my desktop, I'm going to go in here. Nope, that's not it. That's it. And again, you can open this NC birth data file, NC birth 800. What it is that it's from a number of years ago. It's data from all of the births in North Carolina over the course of the year, and it's actually a sample from that population. It's 800 randomly selected births from that population. Might have been 50,000 births in North Carolina that year, or more possibly. Okay, and if I look in here, let me find it. There we go. Now you may get a warning. SPSS a few years ago changed the format for their files, the way it saves files. Changed the way the data is encoded. Okay, so you get a warning that says, "Gee, no, that's a different warning. That's a whole new warning." I just click OK. Now this is nope. Oh, you know, I must have opened it. I must have tried to open it in Excel, I guess. Open. Oops. Desktop. I think it was 4. Yep, that's it. Yeah, I used okay, and I need it should be there. Nope, that's wrong file, wrong folder. SAV files. There it is. Excuse me. There's the warning that the actual warning I wanted you to see. SPSS Statistics is running in Unicode encoding mode. This file is encoded in local specific encoding. Okay, basically it's warning you that you may be using an older formatting in that file, and it's asking, do you want to open it? What encoding method you want to use in it? So basically, don't worry about it. It doesn't matter because it opens either kind of file. So ignore that. Just say OK and ignore that, and you'll be fine. Okay. In the long term, if you're really working with important data, you're going to be entering it from scratch, and it will use the more modern encoding technique. Okay, so let's look at this. We have a number of variables here. We have plurality. Who knows what plurality stands for in birth? Right? Well, put it this way: most of them are ones. Occasionally, there's a 2. Yeah, number of babies that are born out of that pregnancy. Sex, male and female. Right? Obviously, the baby. Right? So M age, mother's age. Now notice M age, mage, right? I mean, that may not be immediately obvious what that means. That's why labeling is so important. So I'm going to go to the variable view. And in the variable view, there is already a lot of labeling and coding done. This has been pre-coded for you. As we move on in the semester, you may be called on to code this for yourself. In fact, when you get to the point where we're talking about a project at the end of the semester, we may just give you a bunch of data and hand you a code book. And for each variable, you might have to look up all the details for that variable and change the coding in SPSS so SPSS understands what kind of variable it is. It's important because if SPSS doesn't identify it as the right kind of variable, it either may not process the data properly or it may not allow you to run certain operations because it doesn't recognize the kind of data that you would need to do that on. Okay, so we got gender, it's sex of the child, the age of the mother in years, marital status, and so on and so forth. So just as I did before, I can now do descriptive statistics. Now, some of this stuff, for instance, marital status, nominal variable. Am I going to do descriptive statistics there? What kind? Analyze, descriptive statistics. Marital status is a nominal variable. So I'm just going to count, right? How many married, how many unmarried women? Not means, not standard deviations. So let's find marital status. Move that in there. I'll go into charts. I'm going to use a bar chart this time. And this time I'm going to put percentages. Okay, just to change things up a little. And I'll click OK. Okay, here's our output window. Now notice on our output window, all of our analyses are still here. And there's a table on the left that summarizes those analyses. So if you've really been working on this for a while, you have a lot of stuff here. First of all, you should save it every once in a while, right? And you want to go back to this analysis, you can just click on it, it'll take you quickly to that analysis. But they just pile up like a ticker on one of those calculators where, like a paper stream on one of those calculators that produce a ticker. So here we go. So let's see. We have 67.1% of them are married, 32.9% are unmarried. Here's a bar chart that shows you the relative percentages of unmarried versus unmarried. Notice that the y-axis is labeled percent and numbered percent instead of numbers like 700 and 320 or something like that, right? There's percentages there because I chose to have it displayed as percentages instead of frequencies, just raw numbers. Okay, let's calculate descriptive statistics for one of the numerical variables. Analyze, descriptive statistics, explore. Okay, and I'm going to move in here. Let's see. Weight gain during pregnancy. Let's move that into my dependence list. And I'm going to ask it to do all those statistics. And on plots, I'm going to ask it to do a histogram. And I'm going to say, okay, let's go ahead and do that. Okay, so now let's see what we got here. Here's our all our cases. There's actually 777 valid. Oh no, I'm sorry. There is 800 total cases, but only 777 were actually used in this analysis. What happened to the other 23? Must have been blank. Must have been no numbers in it, right? So that's why you'd only use 700. So that's one of the reasons why you get this case processing survey. 97. So about 3% of the cases were missing information there for this variable. The mean weight gained during pregnancy was 30.58 pounds. We got a confidence interval. We got a median was 30 pounds. Looks fairly. So far, looking just at the median and the mean. Let's see. They look pretty close, right? The mean's a little bit bigger. It looks like it might be skewed to the right or the higher numbers slightly, right? Let's take a look at the histogram, see if that's true. Well, yeah. In fact, look at that. There are some higher values here. There's one all the way up here. Somebody gained 80 pounds. There you go. Right? There's some values here. There's some these are skewed to the right. Most of the values are here, and there are some very high values, higher values that are skewing the mean, pulling the mean to the right or positively. away from the median. Okay, here's a representation. Why do you think this stem and leaf plot exists? See these things over here? They're called gray hairs, right? Do you think we had nice pictures on these computers when I first started working with them? They didn't have graphics on computers in those days. That stem and leaf plot is there because that's the way we used to display stuff. We used to use ASCII characters to represent shapes and charts and so on and so forth, right? So I guess you can. It really is kind of the same thing. I mean, I guess you could argue that it might be better if it did it that way. But then it makes less sense. You got to read the numbers, right? So in other words, like these zeros, they are really 44 pounds. They are really 10 pounds. These are really 20, 20, 20, 20, 20, 20, 20, 20, 21, 21, 21, 22, 22, 23. And you got to read the numbers. So it probably makes it more practical, lay it on its side. And here's our box plot. Now our box plot has remember we said that they were skewed positively. In other words, there's some higher values that are away from the median, far away from the median. Okay, and these are those values. What do you think those numbers represent on those little bubbles? Right, those represent the subject, the line on SPSS. In other words, this is the 60-second subject. There's one that was 80 pounds was the 750 subject. If I go back there and I look, so you can go back here and you can say to yourself, gee, trying to analyze why are these values so different than all of the others? Let's see, weight gained, 7, what did I say was 7 what? 750? There it is, 95 pounds, right? Okay, maybe that's a typo, right? You have an opportunity to go back there and examine that data to make sure that it's correct, right? And also find out why it's so much different than all the other values and whether or not there's a reason why you might not want to include it as part of your study, when you might want to filter it out. Okay, so this really gives you a lot of information. So now, of course, this is just for this particular numerical variable. Now, I may be interested. What did I ask you to do for the homework? I want to try and not do the whole homework for you. I'm not trying to choose variables. Maybe they're a little bit different. But what did I choose for the homework? I'm going to start with this numerical variable, weight gain. Let's see if women who smoked gained the same amount as women who didn't smoke. How about that? Okay. So what am I going to do? I'm going to take my numerical variable, weight gained, and I'm going to break it up into two groups. I'm going to factor into two groups: women who smoked during pregnancy, women who didn't smoke during pregnancy. Analyze, descriptive statistics, explore. And I'm going to move into my factor list. I'm going to move smoking status, smoke during pregnancy. If I hover over this, it'll give me more information. Smoke during pregnancy, the variable name is smoked. Okay, and I'm going to click OK. All of these have not changed unless I close and open the file. Okay, let's see what we wind up with. Okay, so let's see. There were 664 women who did not smoke. There were 113 women who did smoke during pregnancy. That gives you an idea that this is an older survey, right? Probably at least 15 years old or something like that. Because nowadays, you would expect far fewer women to smoke during pregnancy, certainly far fewer to admit smoking during pregnancy. Right? So let's see what we got. Mothers who did not smoke during pregnancy gained 30.65 pounds. Mothers who did smoke during pregnancy gained pretty much the same thing, 30.19 pounds. Okay. Here's a histogram for women who did not smoke during pregnancy. Women who did smoke during pregnancy. See, these bars look a little bit different because not as many women in that survey, in that group. And here's our histogram, right? Side by side, but pretty much the same distribution, the quartile ranges. Even the presence of outliers looks pretty much the same. So now again, copy and you can paste these. Yes. Hopefully I picked out for you one where there's a difference, an interesting difference. If not, tell you what, try a few of them. I'm going to warn you right now, As far as women who drank during pregnancy, the number of women who reported drinking during pregnancy, the number is very small number of women. It's likely you won't be able to do anything, any interesting analyses with those because so few women admitted to drinking during pregnancy. What were you going to ask? Excuse me?
The bins of Instagram?
Oh, that's a good question. I don't remember. Let me see if I can do it in here. I don't remember. I think it's in here somewhere. Elements, options. It's in the chart here. Unbin element, show grid lines. Here, we go into the help, and let's go into topics. No, it didn't come up. I don't see it. I'm pretty sure it's in here somewhere, but I don't remember exactly where.
I'm trying to update it. That's just.
Yeah. Yeah, no, she means in other words, see over here, for instance, you notice that each bin represents, see, like we got 1, 2, 3, 4, 5, roughly 5 bars between 20 and 40. So each bar is worth roughly 4, like 20 to 24, 24 to, she wants to change that. So maybe it's like each bar is 2 or each bar is 6 or something like that. And there is a way to do that in here. Oh, wait, I think I got it. I think I may have it. Chart size. Well, no. Yeek. I'll tell you what. I'll tell you what. I'll go on YouTube. Everything in the world is on YouTube. You can do brain surgery now on YouTube. I'll go on YouTube and I'll figure out how to do it. And I'll post it on Blackboard. But I don't recall. I'm 99% sure it's buried in the editor for the chart. Yeah, that's what I just did. I didn't see. Yeah, but again, oh, here you go. No, that's the increments. That doesn't change the number of bars, the number of bins. We want to change the number of. We. Okay, how are we doing on time here? We're at 7:31. Okay, I want to talk about one other thing. Okay, before we quit tonight. What time does the class end? 7:50. Oh, I hate to make you stay here to the bitter end. I'm going to try and do this very quickly. Later on in the semester, I hope this will cut off some questions. Email me if I forget, email me, and I'll post how to do it. There's probably a way in the syntax to do it for sure. One of the things we're going to find is that when we're working with, later on in the semester, when we're working with raw data from surveys, tremendously large surveys that we'll be looking at. For instance, there's something called the New York City Community Health Survey. Anybody know what that is? Anybody seen that before? New York City Community Health Survey. Every year, New York City Department of Health does a phone survey they manage to get 8,000 people. I don't know how many people they actually call, but they managed to get 8,000 randomly selected people to sit on the phone to answer 150 questions, believe it or not. Now, there may be some incentive. I have the New York City, the EPA, Safe Drinking Water Act requires that localities, when they test for lead, since most of the piping that's associated with lead is in homes and buildings, not in the street mains, they require the city to do a certain number of samples at the point of use, at the tap. And I have a lead main in my house. I work in air and water testing, so like the shoemaker's kids, I've been living with a lead main for the last 25 years, and it's my business. Somehow or other, I never got around to changing it. But they know that I have a lead main. And about 5 years ago, they started sending me sample bottles, take samples and send them to them every 6 months so that they can satisfy, along with many other homeowners, I would guess, not many, but some other homeowners, so they could sample buildings that typically have this kind of piping. And in return, I get a $100 deduction on my water bill as an incentive for doing these samples twice a year. I suspect maybe this might be an incentive for sitting on the phone for an hour with these people and so on. But they have something called the Community Health Survey. It asks various questions. It asks some very personal questions about mood, about have you been depressed in the past year, They're anonymous, of course, but they're pretty personal questions. And there's a lot of them. Consumption of fruits and vegetables, asthma, whether you had influenza shots, and so on and so forth. Very frequently at the end of the semester, we use this data, right? And the only problem with this data is when they collect all this information at the end of the year, they may find that of those 8,000 people, 2,000 of them are in Manhattan, 1,000 of them are in Queens, 1,000 of them in Brooklyn, so on and so forth. They may find that they're underrepresented for people in Brooklyn, right? So they take that data in Brooklyn and they weight it more heavily than where they collected too many samples. So what they're doing is they're standardizing the data. They're adjusting the data. Okay, I'm going to give you an example of it where we are looking at data that has a particular confounding factor in it, which is a problem because of the way that it's a good random sample. It's not like this problem where we didn't get a good random sample, but this problem is just part of the nature of the population, which introduces a confounding factor. Okay, and what I'm going to do, this is based on something that the New York City Department of Health publishes every year, called the Morbidity and Mortality Report, or Vital Statistics. New York City Vital Statistics. Who knows what vital or vita means in Latin? Vita, life, right? Life statistics. Okay, so, New York City Vital Statistics, here we go. And you'll see that they have a number of them here. Here's our annual report for 2015, and there's an archive of vital statistics annual reports going back to 1961. I'm going to click on this one, and if you look at this, the opening page is a summary of the crude mortality rates in New York. When I say crude, it's not adjusted for anything. It's just the number of people per thousand population that died that year in New York City. And if you look, back in these days, back in the start of 1800, they started keeping records. Periods when 50 people per thousand died in New York City. That includes a fairly young population, right? So why did that happen then? Well, we had a cholera epidemic, another cholera epidemic, a smallpox epidemic, so on and so forth. Here, the most recent big spike is over here in 1918, the pandemic flu. Of course, every year now we're worried about a pandemic flu coming back and getting another big spike in the mortality rate in New York City. Okay, if you look down here, what is today? Today's September 11th, right? 9/11, right? If you look down here, they make an inset here because if you look at the chart, it's very smooth going down over time, but it's very smooth. They put this inset in here to let you know that they did not include the mortality from the World Trade Center in 2011. They probably have a reason for that because it doesn't fit in with their tracking of disease rather than crime and stuff like that, but basically criminal actions and stuff. So this is what it would have looked. There would have been a bump down here like that if they had included those 3,000 or 3,500 deaths in 2011. But if you go through this now, it has many tables that give you information about the life expectancy in different areas of the city, about mortality rates from different diseases, the actual literal counts of the number of deaths. For instance, leading causes of death in New York City, top 10 leading causes of death ranked by age and gender. So for instance, if I go here to 15 to 24 years, the leading cause of death was assault or homicide for 15 to 24 years old during that period of time during that year. Okay, and how many of those? 101 of those were males, and 7 of them were females. So we have some interesting information here. I'm going to focus on one: diseases of the heart or cardiovascular disease. For that age range, there were 15 deaths in all of New York City during that period. If I go spin up to 45 to 55, now let's see. Whereas diseases of the heart now up to number 2, and there were 827, and so on and so forth. And of those 827, so many were male, so many were female. I'm not looking at that right now, but I can literally put together a summary by age range of how many people died from cardiovascular disease in New York City. And we have on Blackboard, we actually have a file like that. Okay, I'm going to open that up now. Let me find it. Okay, this is not from 2015, it's from an older set of data. There we go. Oops, that's an older one. That's a different one. There we go. Let me blow this up a little bit so we can see a little bit better. Okay. Okay, so here we go. Here's my table here. From 24 to 44, there were 146 deaths from cardiovascular disease. There was also information about the population in that age range. Okay, females had 144 deaths, males had 277 deaths. Population of females at that time was, in that age range, was 1,356,000 and so on. So I'm going to calculate an age. So first of all, before I do anything, I'm going to add up all the deaths. There were 12,000 females that died during that year from cardiovascular disease out of 2,854,000. So I'm going to click into this box. I'm putting an equal sign in there. And I'm going to say, well, the rate of death of cardiovascular disease was the number of deaths divided by the population. Now that's going to come back a really awkward fraction, like 0.019, whatever, right? It's going to be hard to interpret. So if I multiply by 100, like if I got 0.25, I multiply it by 100, it becomes percent, 25%. I'm going to multiply by 100,000. So it's a number of deaths per 100,000. I'm going to put parentheses around here first, and I'm going to multiply by 100,000. Okay, 442 women per 100,000 women died from cardiovascular disease in New York City. I'm going to do the same thing for males. That's the number of males that died, smaller population, lower number, but smaller population. And I'm going to put the parentheses around here again. And I'm going to multiply by 100,000. 413. The rate of mortality from cardiovascular disease in New York City was lower for men than for women. Does that make sense? It's counterintuitive, right? You would think it'd be the other way around, right? Well, gee, that's why is that happening? I mean, what is the, you know, why did I get such an unusual result here? Well, first of all, notice, what did I call it here? I called it the crude mortality rate, just the simplest calculation of mortality. Number of people died over the number of people that were living in New York City at that time, right? Well, how about this? How many 80-year-old men do you know versus how many 80-year-old women? Women tend to live longer than men. New York City has an older female population than they have a male population. So since there are so many, and as you get older, the rates of death by cardiovascular disease increase. The problem we have here is not that women are really dying at a higher rate than men are from cardiovascular disease, but their population is older. So by nature, they're going to have more of them are going to die from cardiovascular disease. So to really understand this data, we now have to adjust it. We have to standardize this data and take out that confounding factor of the differences in the distribution of population by age. Okay, so how are we going to do that? Well, first thing we're going to do is going to calculate age-specific death rates for each of these groups. Okay, so this is going to be equal to 146 divided by the population. Okay, that's the rate at which women are dying in that age group. I'm going to copy it down and do it for all the other age groups. Right? You saw me click in there and drag. I could say copy the whole thing, and it would do the same calculation each next to each other. I'm doing this very quickly because I want to just get through this so you guys can see me do it once. 277 divided by the population in that age group. I'm going to copy that calculation down. Okay, so that's the rate. Notice the rate in the oldest age group, the rate is much higher than it is in the youngest age group for the rate of death from cardiovascular disease. In this older age group, it's literally, say 85 plus, it's literally almost 8 per 100 people that die from cardiovascular disease in that age group, plus 85 plus. Okay, and if you click in here, you'll notice that it actually copied the formula down: F10 over E10. This next one's going to be F11 over E11, and so on and so forth. Just by grabbing and recording, copy it down. The other option I would have had, just highlight the whole thing, go up to Edit, and say Fill Down. Okay, and it copies the formula down for the side-by-side columns. Okay, so now I am going to, now the problem here is that this is my female population. Notice how many people are over 85 in my female population, how many are over are 65 to 84, compared to the males in my population that are in my age range. Different distribution for these two populations. So now what I really need to do is take these age-specific death rates, and I need to apply them to the same population instead of two different populations. I could make a population up and say there's just 100,000, there's 1 million people in each age group, right? But that's kind of like cheating a little bit, right? Doesn't make sense. How about if we relate it to something that may make some more sense? Why don't I just apply it to if the total population of New York City, if we applied it to the total population of New York City, female rate, male rate, and compare those rates, maybe we'll see if there's a difference then. So here, I've got, all this is here now is the total population, which is just the males and females added together for that age range. Okay, so I'm going to take all of these numbers, the age-specific death rate here, I'm going to say copy. I'm going to go down here, and I'm going to paste them in here. I'm going to say paste special. And I'm just going to paste in the values, not the formulas. Makes it easy for me because then I don't have to worry about, relating these cell numbers. So I'm going to do the same thing for the male specific death rates. I'm going to say copy, and I'm going to say paste. Paste special, and choose values. Okay, so now I'm going to use those rates to estimate how many deaths I would expect if this population, the same population, were dying at the rate that age-specific rates that females die at and the age-specific rates that males die at. So I'm going to do it for females first. Equals the population times the death rate. Okay, and I'm going to copy that down. And I'm going to add them all together. So how many deaths would we expect among females if this were all a female population? Turns out to be 19,552. I'm going to do the same thing for males. Males equals the population times the male death rate for that age group. And I'm going to copy that down. If I can grab it. Whenever I'm trying to get something done quick, you have these problems, right? Now I'm going to calculate the total number of deaths. I'm going to add these together. Okay, so now I'm going to calculate what my mortality rate is now for females and males. So I'm going to click in here. It's going to be equal to the number of women that would die that would die if they died at that rate. Over the population times 100,000. And the rate is 371. Let's do it for males. Equals males dying at their rate that they die at for different age groups, but now applied to an identical population instead of two different distributions. Okay, it's going to be equal to okay, going to be equal to the total number of male deaths we would expect divided by total population and times 100,000, and that rate is 511. So now we get the real comparison. Men die at a higher rate than females do. We've extracted that confounding variable age by standardizing this data on a single population with a single distribution rather than with two different distributions. two different distributions that where one was biased because there are a lot older people in that population compared to the other population. I'll post something else I'll post another copy of this, a different copy. I'll post this and the answers to it, but I'll also post another file, another Excel file that you guys can play with that is compares deaths due to cancer in Alaska and in Florida. Okay, so what do you think? The problem is going to be the same problem, right? Except where's the older population now? It's in Florida, right, compared to Alaska. Okay, so the crude mortality rate is going to make it look like people are dropping like flies in Florida from cancer because who knows?